Okay, so, whoops. That doesn't look good. There we go. Okay, have a little look here. So using congruent triangles, 4, 5. Now I want you to see there's just one additional part that we add. It's really an important one to our proofs. Here's where it helps us out. If we've got a situation where, like let's take this example. Okay, if we've got a situation where we want to, let's say, what do we want to prove? Okay, I want to show. Here's what I want to do. Good, this is a good one. This will work. I want to show. I want to prove that. I want to prove that angle PQS, so this guy right here, is congruent to angle RQS. Okay? Now, there is no fancy reason that we've got that would allow us to do that. We don't have any kind of alternate interior angle theorem or vertical angles or any such thing that's going to help us out there. Okay? But there is an alternate plan. Now, if I look at those two triangles on the left and the right, are they congruent? Well, we don't know that for sure, but some of you guys are looking ahead a couple steps and seeing that, yeah, they are. It's really easy to show that they are congruent. How many congruence marks do I have in each triangle right now? 2. I just need one more. It's really easy. Where can I get the third one? Yeah, good. Yeah, the third one is really simple, right? I can just say that QS is congruent to itself, and then I got 3 congruence marks in each. And what's the pattern that's going to tell me those triangles are congruent? Side, side, side. Very good. So by side, 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 I can show that the left triangle and the right triangle are congruent. Now here's the advantage of that. Because now that I know those 2 triangles are congruent, even though I've only got 3 congruence marks in each, because I now know the triangles are congruent, I know that all 6 parts of one triangle are guaranteed to be congruent to all 6 corresponding parts of the other triangle. You see what I'm saying? So now we can show that, aha, in fact, these angles are congruent because corresponding parts of congruent triangles, and we know they're congruent now, are always congruent, right? So that's our CPC-TC step. That's our shortcut. Corresponding parts of congruent triangles are congruent. We would instead just write as CPC-TC. Corresponding parts of congruent triangles are congruent. Okay? See how that works? So the way our proof would look then, if we were to write this out, so our proof, well, I guess we didn't write that one out. Anyway, that's we could have easily made that into a proof. Okay, what about this guy? Same kind of a thing. How could I prove here that side AB is congruent to side CD? If I'm given, all I'm given here is that I've got some parallel stuff going on. I know that AB is parallel to CD and BC is parallel to side AD. Okay. There's really no way I can directly say that AB and CD have to be congruent, but what if I take those 2 triangles? Those would be pretty easy to show congruent, wouldn't they? Not as easy. I don't have any congruence marks to start with, but I could get 3 pretty quickly, couldn't I? Well, where's the free one, essentially? BD. Yeah, they share side BD, right? So I know that BD is congruent to itself by what property? Reflexive property. Good. Okay. Good. I could do alternate interior, couldn't I? If I extend side BA like this, side AB and side CD, and here's my transversal, well then there's my parallel lines in a transversal, right? Yes. Yes. So, okay. So then, do you see there that I could say these are alternate interior angles? Right? Everybody with me?
Yep.
Okay, that works. So those two are congruent. Now, if instead what if I do this? What if I make these lines my parallel lines, and I extend that transversal? Then I've got those two angles are congruent by alternate interior angles, right? Okay, good. So we got a lot of stuff then. Now we've got our 3 congruence marks, don't we? So what's going to be the pattern that makes the left bottom triangle congruent to the top right one? Oh, okay. Okay, wrestlers, go.
Good luck. See you later.
See ya. Good luck.
Good luck, Carol. I remember when I used to wrestle last year. Early retirement.
Early retirement. Okay. So now, what's my pattern? Why are those triangles congruent? Angle, side, angle. Everybody see it? Okay. Everybody see it?
Yeah.
So now that I know the 2 triangles are congruent, I've already shown they're congruent, right? AB, doesn't AB correspond to CD in those 2 triangles? So what's the reason then I could give why that guy is congruent to that guy? Even better. What's my reason? I went through all that trouble. Now, don't say anything for a second. I'll have people raise hands. Okay, so I went through all that trouble of showing the 2 triangles are congruent. Why? What was my point? You got to kind of put this out. I want you to see this strategy. So just really focus here. Everybody, heads up, focus real hard here for a second. Okay, we went through the hassle of showing that the bottom triangle, which is going to be orange, so the orange triangle is congruent to the gray triangle. That's a little hard to see, but the orange and the gray triangles are congruent, right? We went through the whole hassle of saying that so that we could show that side AB is congruent to side CD. Why? What's my reason? Because you could turn the triangle around. Shortcut? CP CTC. There you go. That's it. CPCTC. Right? Okay, we got to show the triangles congruent first, then we get the corresponding parts all being congruent. In this case, we only wanted those 2, right? You getting it?
I got it.
Okay. A little bit. Let's do one more, and then you'll have it. Okay. Okay, let's try this guy. Is this one where I get an actual? Yes, it is. Okay. Gotta go back. I like that. Okay, prove. Given some stuff. Given that A is the midpoint of MT, so this is supposed to be, I don't know, it's got somehow cut off here, but that's supposed to be an MT, and that's supposed to be an R. That's an A. A is the midpoint of MT, A is the midpoint of SR. Prove that side MS is parallel to side TR. That's kind of a tough one. Okay, let's see if we can just do this proof, write it out. We'll put in the congruence marks and just say the reasons first. Okay, vertical angles. There's one thing we have. No, let's do the given first. Vertical angles is a good idea. Hold that thought. A is the midpoint of MT. So what? What does that tell us? Okay. Good. It tells us that MA is congruent, side MA is congruent to side TA. Now, what's my reason for that? If you had to come up with a reason. Perfect. Definition of midpoint. That's what a midpoint does. It's in the exact middle, so it breaks the segment into 2 congruent parts.
So would that be RA and AS the same?
Perfect. So segment RA is congruent to segment SA. Same reason. Definition of midpoint. I got my 2 marks. Someone already suggested vertical angles. And I've got it, right? I've got the triangles congruent now. The left triangle and the right triangle are congruent by what patterns? SAS, right? Everybody see that? If I walk around the outside, look, I've just got side, angle, side on the left triangle, right? Right triangle, side, angle, side. Make sense? So we got the triangles congruent. Now, if I want to show that MS is parallel to RT, that's my goal. I'm going to have to use one of my converses, aren't I? Remember that stuff we talked about, two lines and transversals? The converses were the ones that said if corresponding angles are congruent, then the lines are parallel. If alternate interior angles are congruent, then the lines are parallel. So do you see a pair of angles up there that could be considered alternate interior angles, for example? Yeah, R and S, right? Everybody see that? If I extend these two sides,
You don't have to. Just
right? If I extend that side and I extend that side, and there's my transversal, right? Now you gotta make it pretty plain. Here are my two lines cut by a transversal. If I could just show that those two angles were congruent, then what would be the reason that those lines would have to be parallel? Alternate interior angles, converse. Excellent. Okay?
It makes a pretty cool T-piece.
That was pretty cool.
Okay, so all right, so I have to show those angles are congruent. How can I do that? It's a freebie. Okay, but what's my reason going to be? Okay, now if I were to say, now this is kind of important. Everybody, if there are any phones and stuff, get those put away. I don't want to see anybody looking down. Everyone's looking up right here. Okay, now if I wanted to write down a triangle congruent statement, this is important. Let's do this. Triangle. If I'm going to call this triangle, how about if I call this one ASM? That is going to be congruent to triangle what? What on the right triangle, what's the vertex that goes with A in the left triangle? A, right? Because the single loop goes with single loop, right? Okay, so A, and then S is the one that is going to be pinched between. Now look, if I look at this triangle over here, I don't really know, I don't have a number of loops there yet, but angle S has as one side the 2 dash segment, and then it's got the empty segment on the other side, right? See what I'm getting at?
Yeah.
So the sides of angle S have 2 marks on one side and none on the other. So up here, that's going to be R, isn't it?
Yeah.
Right? So S goes with R, and then M must go with T. Agreed? Because I have to get the corresponding angles lining up. So then doesn't that tell me that angle S corresponds to angle R in those triangles?
Yeah.
So I got it. S is congruent to R by what reason? No. I just showed the triangles were congruent. So then I can pick those corresponding parts of the triangles, and they have to be congruent by what reason? C, P, C, T, C. Corresponding parts of congruent triangles. Right? So if we want to look at that proof, here's what that one looks like on paper. Let's get rid of you. Right? So, oops, messy. Okay, there's given. Midpoint stuff is given. We know definition of midpoint tells us this stuff, right? We said we had angle MAS is congruent to angle TAR. So we had this, right? We've done this so far. That was vertical angles, right? Then we said triangle MAS is congruent to triangle TAR by side angle side, right? And then angle M is congruent to angle T. We said S and R, but we could have done M and T, right? By CPCTC, and we don't have to write all this out. CPCTC, and then finally, if I know, I guess we actually didn't finish it up, did we? If I know that those two angles are congruent, then now is when I can say, okay, if parallel lines are, whoops, wrong transversal. What? Well, that's wonderful. Here's my transversal. If alternate interior angles are congruent, then the lines are parallel by alternate interior angles converse. Make sense?
Yes.
Got it. All right. You guys are in great shape. Okay.
Not really.
Sure. All right.